Hey there guys, in this video we're going to be solving a really interesting system of equations with two variables where we need to solve for x and y. So first of all, let's go ahead and talk about the first equation, which is x squared plus y squared plus x minus y equals 6. So looking at this equation, we have a sum of two squares and a difference on the left hand side. So having the sum of two squares kind of gave me the idea that we need to complete the square, but the thing is we can complete the square in two ways. We can either add 2xy and then get x plus y all squared, or we can subtract 2xy and get x minus y all squared. Now, considering the fact that we have x minus y in our expression, it kind of makes sense to go with the second one and have x minus y to the power of 2 instead of having x plus y to the power of 2. So let's go ahead and subtract 2xy. And then add 2xy to balance it up. And then let's go ahead and replace these three with x minus y all squared. And this is our first equation. So let's go ahead and write it down here. So we have the quantity x minus y all squared plus 2xy plus x minus y equals 6. Next, let's go ahead and talk about the second equation, which is x cubed minus y cubed minus x squared times y plus x times y squared equals 5. So at this point, what I'm going to do is to factor the left-hand side as much as I can. So I'm going to start with factoring this difference of two cubes. So I can factor this into x minus y times x squared plus y squared plus x times y. And then I'm going to pull out a negative xy out of these two. So I'm going to get negative xy times x minus y. And then, since we have x minus y as the common factor, we can pull it out. And if we do so, we're going to have x minus y times x squared plus y squared equals 5. Now, notice that we have a sum of two squares again, so we can complete the square the same way we did before. So I can say that we have x minus y times x squared plus y squared minus 2xy plus 2xy equals 5. Now let's go ahead and replace this with x minus y quantity squared. So we're going to have x minus y times the quantity x minus y all squared plus 2xy equals 5. So this is our second equation. It is x minus y times the quantity x minus y all squared plus 2xy. And it equals 5. Now, looking at these two equations, we can see that they have one thing in common, and that is on the left-hand side, we only have x minus y and x times y. So let's go ahead and use the substitution method, and let's say that a equals x minus y, and b equals x times y. In this way, our system of equations is going to be equivalent to a squared plus 2b plus a equals 6, and a times a squared plus 2b equals 5. So this is a much simple system of equations that we can solve. So let's go ahead and solve for a and b. To do that, let's go ahead and subtract a from both sides of the first equation. So we're going to have a squared plus 2b equals 6 minus a. And we also have a times a squared plus 2b equals 5. So based on the first equation, a squared plus 2b, which is this, is 6 minus a. So I can replace this with 6 minus a and get an equation in terms of a, which I can solve for a. And then by using the values of a, I'm going to be able to solve for b. So let's go ahead and do that. Let's say that a times 6 minus a equals 5, which means that 6a minus a squared equals 5, which means that a squared minus 6a plus 5 equals 0, which means that a minus 1 times a minus 5 equals 0, which means that a equals 1 or a equals 5. Now, notice that the first equation of system of equations was a squared plus 2b equals 6 minus a. Let's say that a equals 1. In this case, 1 plus 2b will equal 6 minus 1, which means that 2b will equal 4, which means that b is going to be 2. So if a equals 1, b is going to be 2. But if a equals 5, we're going to have 25 plus 2b equals 6 minus 5, which means that 2b will equal negative 24, which means that b will equal negative 12. So that means that we have two cases for the values of a and b. So let's go ahead and recap everything we know up till this point. So we know that a equals x minus y and b equals x times y. And we have two cases, either a equals 1 and b equals 2, or a equals 5 and b equals negative 12. So let's go ahead and solve for x and y in both of these two cases. And let's start with the first one, where a, which is x minus y, equals 1, and b, which is x times y, equals 2. Now, in order to solve for x and y, we need to go ahead and use these two values to solve for x plus y, and then by doing that, we're going to be able to solve for x and y. To do that, let's go ahead and square both sides of this. So we're going to have x squared plus y squared minus 2xy equals 1. And then let's go ahead and add 4xy to both sides to get x squared plus y squared plus 2xy equals 1 plus 4xy. Now, obviously, the left-hand side is going to be the quantity x plus y all squared, and the right-hand side is going to be 1 plus 4 times 2, because x times y is 2, so the right-hand side is going to be 9. So if I take the square root of both sides, I'm going to have x plus y equals positive or negative 3. So basically, we have two cases for the values of x plus y. If x plus y equals 3, since we know that x minus y equals 1, we can say that x will equal 2 and y will equal 1. But if x plus y equals negative 3, since we know that x minus y equals 1, we can say that x will be negative 1 and y is going to be negative 2. By the way, looking at these two solutions, we can see that x times y is going to be 2, so they are valid solutions. So next, let's go ahead and talk about the second case, where a, which is x minus y, equals 5, and b, which is x times y, equals negative 12. So again, we need to solve for x plus y, and to do that, we need to square both sides of this. And if we do so, we're going to have x squared plus y squared minus 2xy equals 25. And then we need to add 4xy to both sides. So we're going to have x squared plus y squared plus 2xy equals 25 plus 4xy, which means that x plus y all squared will equal 25 plus 4 times negative 12, because x times y equals negative 12, which is equal to negative 23. But notice that since x and y are real numbers, x plus y to the power of 2 cannot be a negative number, which means that we cannot find any solution from the second case. So we only have two solutions for our system of equations, and they are this and this. Great, so this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoy watching this. Hopefully I will see you later. Goodbye for now.